Welcome to part 2 of our scientific notation series. In this video, we're going to continue in our guided notes on page 3, right where we left off. We just did some basics, but now we're going to perform operations that include scientific notation. You'll see here on the left, we have a problem where we're multiplying two different things in scientific notation. Let's go ahead and do that. So when you have two different scientific notation expressions that you're multiplying by each other, it's good to remember that, hey, we can multiply in any order. I can go ahead and I can multiply my decimal parts together, and then I can multiply my scientific notation exponents, powers of 10 together. So let's do that. We can regroup this as 2.3 times 4.1, and then times 10 to the negative 5 times 10 to the 8th. I know that when I'm multiplying powers with the same base, I can just add the exponents. So 8 plus negative 5 is 3. So this is times 10 to the third. And I can go ahead if I need to and use my calculator to multiply 2.3 times 4.1. And I'll get 9.43. So my answer in scientific notation is 9.43 times 10 to the third. And that works because I have a number from 1 to 9 plus the decimal part, right? Times 10 to the third. So that fits my criteria as scientific notation. Let's look at our division example on the other side here. 1.44 times 10 to the 6th divided by 1.2 times 10 to the negative 2. I'm going to go ahead again and take my powers of 10, and I'm going to take care of that part, simplify that part, and then I'll go ahead and I will divide my decimals. So I have here 10 to the 6th over 10 to the negative 2. Hold on there. 10 to the 6th over 10 to the negative 2 is going to be 10 to the 6th minus negative 2, right? Because I subtract my exponents when I have a division sign. So that'll give me 10 to the 8th, actually. And I'm going to use my calculator to do 1.44 divided by 1.2. And that's equal to 1.2. So I have 1.2 times 10 to the 8th as my final answer here. Oftentimes we'll use scientific notation in the capacity of an applied problem. Let's read this one. The number of hairs on an average human head is estimated to be about 1.5 times 10 to the 5th. If there are approximately 6 times 10 to the 9th people in the world, let's estimate the number of human hairs in the world. So there are 6 times 10 to the 9th people, and each of those people has 1.5 times 10 to the 5th hairs. So we're going to multiply the number of hairs by the number of people having those hairs. We can reorder this, remember, as 1.5 times 6, and then times 10 to the 5th times 10 to the 9th. For my powers of 10, I can add the exponents, right? So we get 10 to the 9 plus 5 is 14. And then I'll use my calculator to help me as I do 1.5 times 6. And I'll end up with the answer of 9 times 10 to the 14th hairs. That's how many human hairs are in the world. Imagine that. Another example, at the very best, a light microscope can distinguish points 2 times 10 to the negative 7th meters apart, whereas an electronic microscope can distinguish points that are 2 times 10 to the negative 10th meter apart. What the second number is how many times as great as the first number. To figure this out, we could just determine how many times one of the numbers goes into the other number. So I'm going to say 2 times 10 to the negative 7 divided by 2 times 10 to the negative 10. My powers of 10 can be divided. So I have here, that would be 10 to the negative 7. And this is a negative exponent. I'll say times 10 to the positive 10. Remember, flip the spot that it's in if you have a negative exponent. You'll ask why I didn't do that to both of them. It's because now I can add them. 10 to the negative 7 times 10 to the negative 10. We could say negative 7 plus 10 gives me 10 to the third. And there I had 2 over 2. 2 over 2 is just 1. So the factor to get from one of these microscopes to the other, they're distinguishing distances, it would be 1 times 10 to the third. Now we're going to use our calculators. I want you to go ahead and put 700,000 times 23,000 into your calculator. When I put that in my calculator, I got 1.61 E10. Now, I know my teacher wouldn't allow me to write E10 on my paper, so I'm going to change that to scientific notation. And that would be 1.61 times 10 to the 10. So we take whatever we see E here, we make it times 10 to whatever number you see after the E. Now we want to write our answer using standard notation. So I'm going to take my 1.61 and then, it's a positive exponent, so that means I'm making a bigger number. I'm going to move to the right. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bumps there to the right, and we'll fill those spots in with zeros. Then I'm going to rewrite the number. There's 8 zeros. 2, 3, 4, 5, 6, 7, 8. That's my number, but remember between every 3 place values for integers, we are putting commas. So there you go. There you have it. 16,100,000,000 is what we come up with. Now let's try dividing 8 by 4,501 in our calculators. My calculator gave me the result as 0.0017773828. I want to write that in scientific notation. So to write that in scientific notation, I'm going to take the result in my calculator. I'm going to take the decimal place and move it. So I have 1, 2, 3. I'm going to move it over 3 so it's between that first non-zero integer I see and the second non-zero integer I see. So I get 1.77732828 times 10 to some number. Now my original number, it's a decimal, it's less than 1, so I know it's going to be a negative exponent, and it's going to be negative 1, 2, 3. Negative 3, because I moved over 3 bumps. Or 3 place values, we'll say. Now we want to write using standard notation rounded to 4 decimal places. What our calculator gave us to begin with is definitely standard notation. But we need it rounded to 4 decimal places. We know how to round, so this is no big deal. So 4 decimal places, that'll be 1, 2, 3, 4. That's 7 there. So we're going to look next door, and our number to the right of the 7 is another 7, which is greater than 5. So we're going to round up. So we'll have 0.0018 would be our answer, rounded to 4 decimal places. And there you have it. That is our scientific notation tutorial. I hope you found it helpful. Please let me know if you have questions.